In this lesson, we're going to take a look at how electrons are arranged around the nucleus in an atom. And we sort of have an idea about this because we're familiar with the Bohr model of the atom. The Bohr model of the atom shows electrons moving in circular energy levels around the nucleus. Remember, we figured this out by looking at the light emitted when we excited electrons. We saw when we took a hydrogen tube, we got out a few distinct colors of light, and we figured out that that happened because electrons could fall from this energy level and emit a color of light. They could fall farther and emit a different color of light, higher energy, higher frequency light, or fall here and emit even yet another color of light. So Niels Bohr is the one who put all this together and figured out, hey, electrons must have distinct, discrete energy levels that they can move between, because we always only get line spectra from looking at the atoms giving off light. And it's the transition from an electron from a high energy level to a low energy level that produces the line spectra. Well, the Bohr model works for a little bit of stuff, but if we get much beyond hydrogen, it gets a little bit more complicated. And that's because electrons move in 3 dimensions. They're not contained in circular paths. And within those paths, they actually have regions of space where they're likely to be found. So we have to take these circular orbits and extend them into 3 dimensions, which we call shells. And we have to divide those shells up into regions of space, which we call orbitals. Now, orbitals are regions of space where electrons are likely to be found. And that should say 2. Only 2 electrons fit in any given orbital, which means we're going to need lots of orbitals, because if you think of something like lead with 82 protons, it's got 82 electrons, and that means we're going to need at least 41 orbitals to pack all those electrons into. So now we've got to figure out, okay, what do these orbitals look like? Where are they at? How do we put electrons into them? Okay? Well, it could be complicated, but happily it's not. The periodic table is arranged to show us how electrons go into orbitals, and there's a repeating pattern of orbitals. So orbitals come in a variety of shapes. We're going to look at 4. That's where most of your electrons are found, 4 distinct orbitals. And they're given names, and the names are super complicated. They're s, p, d, and f. Okay, so the s orbital is spherical in shape, and there's 1 s orbital per energy level. So on the first energy level, there is an s orbital, which is a sphere, and it holds 2 electrons. But that's it. That's the only thing in the first energy level. It's just that 1 s orbital. The next energy level also has an s orbital. So this is energy level 1. I'm going to go ahead and grab another color. And energy level 2 also has an s orbital, which is a bigger sphere around it, but it's also got p energy levels. So the first energy level, 1s orbital, holds 2 electrons. Second energy level, 2s, but it's an s orbital, it holds 2 electrons. And it's also got 3 p orbitals in it. Now a p orbital is dumbbell shaped, sort of. Okay? But there's 3 of them. So one of them goes left to right, one of them goes up and down, and a third one of them in 3 dimensions, it would come out of the screen and go behind the screen. And that has to get stacked on top of these s and p orbitals that are already here. So there's my second energy level. My third energy level, again, that repeats. We have another s orbital, which would be bigger out here. And then we have our p orbitals, which repeat again, bigger this time. And then we have a d orbital. Now the d orbital, I'm not even going to attempt to draw. It's cloverleaf shaped, and there's 5 of them on the third energy level and every energy level after that. And then once we get to the 4th energy level, there's also an f orbital. Here's what they look like. Okay? The s orbital is spherical. The 3 orbitals that make up the p group are dumbbell shaped, and they move up and down, left and right, and into and out of the screen. Okay. The d orbitals, I said, were cloverleaf shaped. That's what these guys look like, except for this one. It's the oddball out, but hey, we go with it. And then there's this d orbital, d orbital. So if you look, 2 electrons fit in any s orbital, 2 electrons fit in each p orbital, which gives us a total of 6 electrons. In the d orbitals, there's 2 in each one, which gives us a total of 10 electrons, and then 2 in each one of these, which gives us a total of 14 electrons. So the electrons start to add up in a hurry, and you'll notice we don't have f orbitals on the first energy level. Because the first energy level is small, it doesn't take up very much space, f orbitals don't fit. In fact, p orbitals don't fit on the first energy level. First energy level only has s, second energy level has s and p, third energy level has sp and d, and fourth energy level has spd and f. So we have to be a pretty long ways from the nucleus before we even start getting f orbitals. So now, how do we fill these things up? Well, we have to remember that they fill from lowest energy to highest energy, not numerically. Electrons don't like each other, but they do like the nucleus. Okay? So the energy of the orbital depends on its size and shape, its proximity to the nucleus, and other electrons in the orbitals. So we've got some electron repulsion happening between electrons in the same orbital, and then we also have attraction to the nucleus. And s and p orbitals tend to be roomier than d and f orbitals, which means the s and p orbitals are going to fill before d and f orbitals. You don't have to remember all these rules. Okay, the periodic table is arranged to show us how electrons are going to fill. So let's take a look at that. If we look at the periodic table, each block, and I'll show you what I mean by block, it corresponds to a specific group of orbitals, whether it's s, p, d, or f. And each period represents an energy level. So here's what we got going on. Down over here I have the periodic table of the elements, sort of. It shows us the first block is the first two columns, which we call the s block. The electrons that we're filling into these spaces are going into s orbitals. The block over here is called the p block. Electrons going over here fill p orbitals. This block, the transition metals in the middle, that's the d block. And then this helium is actually part of the s block. And then down here we have the f block. Electrons that are going into these atoms are filling f orbitals. And we'll get a little bit of practice on this in just a second. What order do they actually fill in? Okay, well, this shows me the energy of the different energy levels in subshells and orbitals. So higher energy is higher up, lower energy is lower down. So electrons are always going to fill the lowest spot first. Remember, orbitals hold 2. So the order goes 1s because it's the lowest energy. Then we look 2s. Above 2s is 2p. And then 3s. And then 3p. So far this is numeric. And then 4s. And then just above 4s is not 4p, but rather 3d. So that's the first break that we see. So then 3p, 4s, 3d. Above 3d, the next lowest one is 4p. And then 5s. And then above 5s, we're going to do 4d. Above 4d, we have 5p. Above 5p, we have 6s. Above 6s, we have 4f. Okay, so there's another break in numeracy. And then above 4f, we have 5d. Above 5d, we have 6p. Above 6p, we have 7s. And these two are close, but 7s is just a little bit lower than 5f. And then 6d. Okay, so do I have to memorize that order? No, and here's why. This periodic table down here, or any periodic table, shows us the order they fill in. The only thing you have to remember is the row one back or two back. And here's what I mean. Okay, on the periodic table, this is row or period 1. So this is 1s, and 1 electron fits in it. So we call it 1s1. This is 1s2 because 2 electrons fit in it. And then we go over to the next energy level and we start over. This is the s block. So we have 2s1, 2s2. There is no d block here. So the next thing we see is 2p. And this will go 2p1 all the way through 2p6. Remember, there's 3p orbitals, which gives us 6 total electrons. And then we circle back around to the beginning. And this is our 3, and we're in the s block. And 3s1, 3s2, and then there's no D's here, and so we just jump over to 3p, and again we go from 3p1 all the way up to 3p6, and then we start over on the periodic table, and we go 4s, and it'll be 4s1, 4s2, and then the next thing we come to is right here, and it says D. It says 3D. So even though we're in the fourth energy level, the D's fill after the 4S's, but there's a 3D level. So that means we're going to fall back 1. Okay, so we go 4s1, 4s2, and then the 3D block fills. And then after the 3Ds, we have 4p's again. Okay, so that's not so bad. So then we fill all the way through here, and then we start over at 5s. And from 5s we go to 4d. Remember, we're still just one back. 4d fills and we end up at 5p. 5p fills and we end up at 6s. And then what's next? Well, next is our F block. So we go from 6s to 4f. The 4f is this row. Okay? And after that, we start here again, which gets us back into 5d and then 6p. And then we start over again at 7s. 5f fills, and then we go 6d, and we're out of elements, so it's not a big deal. Okay, so the periodic table is arranged to help us figure out how electrons fill in their orders. Let's look at an example. Okay? So if I wanted to give the electron configuration of oxygen, when I say I want an electron configuration, I want to know where are all the electrons, what energy levels are they in, what orbitals are they in. So to do that, I look at oxygen and I go, okay, so we've got to fill in everything before that. So we're going to start with the lowest energy thing and work our way up to it. So our lowest energy electron is in the hydrogen spot. So we've got an electron in 1s, and we've got 2 of them. So I have 1s, 2. And then I start over and I've got 2s, and there's 2. And now I'm over here in 2p. And how many electrons does it take to get to oxygen? 1, 2, 3, 4. So 2p, 4. So the electron configuration of oxygen is this. It tells me there's 2 electrons in the first energy level in the s orbital. There's 2 electrons in the s orbital in the second energy level, and there's 4 electrons in the p orbitals in the second energy level. Not so bad. What if we wanted to pick something a little bit further on, like say chromium? Okay. Chromium is going to be a little bit more complicated because there's way more electrons, right? Well, it's actually not complicated. It just takes longer to do. So again, I'm going to start with energy level 1, and both of those are full. So I have 1s2. And then I'm going to go to 2, and 2s fills, and then the p's fill, 2p6. And then we're in the 3s, so 3s2, right? We started over here, and then the 3p's fill, 3p6, and then we have 4s, 4s2, and then I have, this is the D block, but remember it's one back, so this is 3, so I have 3d4. So there's the electron configuration for chromium. Okay, I can see it's got 6 electrons in the p orbitals in the third energy level. It's got 2 electrons in the s orbitals in the fourth energy level. Okay, now if I wanted to go to manganese, everything would look the same except this would be 3d5. And then if I want to go to cobalt, this would be 3d7. Okay, so do I have to write this first part if I'm trying to get all the way down to something like tin? The answer is no. There's a shortcut method. The shortcut method is to look at the noble gas before it, because everything up to the noble gas is going to be the same. So we look at that and we say, okay, it looks like krypton. And remember, I'm doing tin right down here, element number 50. It looks like krypton up to krypton. And then we start and we have 5s2, because right after krypton I have 5s. And then I have the D, and this is the 4D, because it's back one. 4D10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm in the P's, that's the 5P2. So I don't have to write the electron configuration all the way up to krypton. I can just say, hey, it looks like krypton, and then tack on these extra orbitals and energy levels. And that's a whole lot easier and faster. So that's how we get electron configuration. It just tells us what electrons are in what orbitals and in what energy levels.